everyone. I am Pravina, working as Assistant Professor in Department of IT in V.S.B Engineering College, Kerala. Now, discuss about the topic of automata theory, which is in the subject from theory of computation. Automata theory. What is automata theory? So, it is the combination of two major branches. One is the computer science and another one is the mathematical. So, how it is related to IT or CS means, yes, it is related because one example. I go with one example. So, let's so one example, C equal to A plus B. So it is a basic addition program. So it is a basic addition program. Means the code is in small manner, and we have to draw a block diagram. Means that diagram is also in a small manner, and we have easily understood that diagram. But in the unsolvable problems, which means the larger size of data or larger size of the formulas, which types of formulas that we have to use means yes, we absolutely we go with theory of computation because the mathematical problem, computational problems are concerned in the theory of computation. In this, there is a main topic is finite automata, regular expression, context-free grammar, context-free language, and push-down automata and the Turing machines. It is the level of from below to higher level. So next one is finite automata. So finite automata, it is the consists of majorly three. One is the input and another one is output and the next one is the states. So what is states, what is input and what is output means if the whatever program we have to be in code means we have to use the input and then input only we get the output. So the input and outputs, these are the combinations we get from the states. So the finite automata is the machine. That machine is already coded with these statements and then we have to derive that what is the answers. Next one, the formal definition of finite automata. So finite automata, so here there is the this is the five tuples. So what are the five tuples means? Q, summation, delta, Q naught and F. F it is the final state. So first one Q. Q it is the states. So I already tell about the state. So what is state mean? You have A, this is one state, and B, this is the another state. From these two states, the inputs are transferring from one state to another state. So this is the purpose of states. So this is the state. The states are represented in the way of capital letters, which means capital A to Z we have used. And the next one is the summation. Summation, it is the alphabet inputs. So what is the alphabet inputs means? We have seen about the numbers, alphabet, we are no. But in EOC, in finite automata, we have the alternate name. So here alphabets. So what is input alphabet means? It is the combinations of 0 to 9 and then small e to small z. So here we have to see one thing. So then states we have used the capital letters, but in the input, so input we have used only small case, and then special characters. So which mean minus, plus, or percentage, and then modo. So these are the special characters also we have to take as input in this finite automata. So these are all the input symbols. And the next one is Q0. Q0 it is the initial state. So example, this is a transition diagram means. So the A is the initial state. Suppose what is the finite state means the finite state is represented by double circle. So double circle means it is the finite state and is a transition function. So what is the use of transition function means we take one input and then we take one state and that state is take as an input and that input is delivered to next state means it is the transition function. So next one, finite automata model. So finite automata model means, so here it represents the tape. So it is the input tape. So in this input tape, we have to insert the inputs. So which means I already said the input alphabets. So that alphabets are present in this input tape. So the one cell, the input tape is partially divided into the cells. So each one it is a cell That one each step contains the one input. That input means it is a specified only a limit. There is no unlimited. So if you have a five input means yes we have only used by only five inputs. So if we do not exit that limit of the inputs. So next one it is the finite control. So the control means so if we read over B is a input means we have to read and complete that B input and then we have to forward to C. Then we have to read the C means next to complete that C, then only we go to A. So this is the finite control work. So next one, types of automata. So here types of automata having two types. One is the deterministic finite automata and another one is non-deterministic finite automata. That we have to see it later. So next one, the representations of finite automata. In this finite automata, we have three representations. So one is the transition diagram, another one is transition table, and last one is transition function. So transition diagram is how we represent a diagrammatic in a finite automata. So this is the basic notations. So here see Q1, it is a state. So normally if we want to represent a state means just we have to put one circle. In that circle it is a state. Then next one is arrow mark. So arrow mark it is the transition. So we have to move from one state to another state means we have used the transition arrow mark. And then next one it is the starting state. If we have starting state means so here see Q1 it is the state. So it is a normal state which means we have to say another name as intermediate state. But starting state means you have to put arrow mark in the first one. So in the circle first one you have to put arrow mark. So which means it represents starting state. And another one is we have put a minus symbol like that means it is the starting state. Because this is two are representing the same start state only. The next one is final state. So Qn, so it's like the so here we have represent a plus symbol. And then next one a double circle. So double circle means it is the final state. So mostly we have used it for start state is with the arrow mark, and then our final state is double circle. So transition table. So transition table we represent the diagram. So before we see the diagram, so that diagram I have to insert in this table. So write example. So we have the states inputs. So this is the states inputs column, and this one is the row. Row is mentioned for input. So listen, in this is important. So listen carefully. So states are in the column base, and the inputs are in the row base. So in this tabular column, the arrow mark is represent here. No. So this arrow mark representing the initial state. So now we have to draw the transition diagram for this transition table. So example A is the starting state. So starting state means we have to put like the arrow mark. And the next one, so B it is the intermediate state because there is no arrow mark or no double circle like that symbol. So here in tabular manner, so we have to use star symbol for final state. So here the star is mentioning for final state. So A and then B is intermediate state and then C is final state. So in transition diagram we have to represent double circle for final state. So next there is the input 0, 1 and the combinations of input transitions are there. So we have to just use that combinations. So A is the initial state, that A is take the input of 0 and move to the A. So here A and then A previous state and next state is same. So it gives a self transition. So this is a self transition. So A take the input and go to same state. So the what input it take means 0. So represent like this. Next one, the state A is take 1 as input and goes to the next state B. So like this we have to draw. Next B. So B take a 0 as input and then it goes to C. And then B take a 1 and goes to A. So which means it is a backtracking. So it is also another topic. So I will later explain it. So 2, 1. And the next we comes to C means C is the final state. So it comes under the C. So C here there is a symbol of hyphen. So here hyphen or phi. So in these two, which symbol are they have used? Which is there is a no transition between the C's. That's only the meaning of the phi. So this is the transition diagram for the transition table. If we ask the transition table means from the we have given the transition diagram. In this diagram, you use as a table. If they ask the transition diagram means use the table and then you draw the transition diagram. So this is the basic representation of transition diagram and transition table. Next representation is transition function. So the transition function is nothing very much as like that. So it is the transition of one state to another state. So example I am here given. So the current state, if we take Q0 is the current state, means that Q0 state take the input of 0 and then transform from that state to another state means Q1. So this is the transition function. So current state take the input to the another state. So this is the transition function. So these are the representations of finite automata. Thank you.